All right, move down to problem 6. Says arrow fired horizontally at, so they gave us the x as 41, and it's in meters per second, so that's good. We don't have to do anything, and it travels so far 23 meters in the x direction. So, and this one I have 23 meters before hitting the ground. From what height was it fired? So these two things are on the x side of the equation, and the answer they want, the height, that's a y problem. That's this down here. That's what we'll be searching for, is how high it is. So we're going to have to use the information from the x side to find something for the y. So over here, I already have two variables on the x side. I got the velocity and I've got the distance. So what I need to do is solve for time. Since I have 2 out of 3, I can solve that. So Vx equals x over t. Since I'm solving for t, I'm going to rearrange this to solve for t, which is x over Vx. So now all I have to do is plug those in. I've got 23 and 41, and I divide, and it comes out to be 0.56 or 0.51. Oops, I lied. 0.561 seconds. So 0.561, that's also true over here on the y side because these t's are the same. So 0.561. Now that I have the time variable on the y side, I also have VI, which equals 0 meters per second. And I have A, which is always 9.81 here on the planet Earth. That gives me 3 variables, and that allows me to solve for y. All right, to solve for y, what I'm going to do is use y equals 1 half a t squared. So when I plug this in, I've got 1 half 9.81, and then I'm going to multiply that by 0.561 squared, and that is going to equal 1.54. So that's how many meters high the table is just solving for this y component, or the vertical in that one.